Hi everyone, I'm Cheryl. In this problem, we're going to find out when our vector valued function is smooth. Now, what does it mean to be smooth? Well, we need to look at two conditions. We want the derivative of my components to all be continuous on an interval I. And then we also need to check to make sure that the derivative is not equal to the zero vector at any point on that interval. Basically, we're trying to avoid cusps or sharp turns, and we want to make sure that when the tangent vector changes, it changes in a continuous manner. Okay, so let's take a look at this particular problem. Notice that the conditions that need to be met all have to do with the derivative. So let's find the derivative of my vector valued function. So the derivative is going to be 2t times vector I plus 3t squared times my vector j. All right, so for my first condition, I want to make sure that all of the components are continuous. Now notice I don't have a component for my k vector, so I don't have to worry about this one. So let's take a look at f prime of t, which is going to be 2t. And I'll also consider g prime of t, which is 3t squared. And I notice that both of these functions are continuous everywhere. So continuous on the interval from negative infinity to positive infinity. Okay, now we need to consider the second condition. When does my derivative of my vector function equal the zero vector? Right? So when does that happen? Well, it's going to equal 0 when 2t equals 0 and 3t squared equals 0. That will give me the zero vector. And if I solve both of these equations for t, I notice that in both cases, t is going to equal 0. Now remember, I don't want my derivative to equal the zero function, and it will when t is 0. So I want to eliminate 0 from my interval. So this is not smooth when t equals 0. So technically the question asks, when is it smooth? Because it's continuous everywhere and the only issue that I have is at 0, my function is smooth on the interval negative infinity to 0 and from 0 to infinity. Now, to kind of get an idea of what's happening here, let's take a look at the graph. If I graph r of t, which is t squared I minus t cubed j, it turns out that it looks like that curve. And notice what's happening at t equals 0. Right here, I've got a cusp, which is why I discovered that my curve was not smooth at that location. I hope that was helpful. Thanks.